All right, so why do we do math? Math is done to help us solve real world problems. That's why it happens. So here's an example of real world problem. Now we're going to go back to a couple units ago where we talked about logs and exponentials and what their meanings are. So key thing to remember is that if I have f of x equals a times b to the x, a and b have roles, right? Your a is going to be your initial amount, your initial value, right? Is this ringing a little bit of a bell? A is our initial, and B is our rate that we're growing at, right? B is our rate that we're growing at. And that rate is determined by either adding or subtracting from 100%. Does that ring a bell? A little bit? Adding or subtracting from 100%, okay? So keeping previous knowledge in mind, we're going to move forward. So it says Rojiza has an above ground pool that holds 20,000 gallons of water. She notices that the pool seems to be losing water continuously through a leak at a rate of 1% of the total volume of water every hour. Write an exponential function of the form f of x equals a times b to the x to model this scenario. And then use the technique you developed in problem 8 to express it as a times e to the kx. We will see if we do that or not. I just don't feel the need or necessary to do that part. But lastly, use your function to estimate to the nearest hundredth the number of gallons of water that remain in the pool. Okay. So we're going to set it up. So what is our A? 20,000 is our A. Agree? Because that's our initial amount. Our B, I'm losing water at 1%. So therefore B equals exactly 100% minus 1%, which is 99%, which equals 0.99. Does that make sense? So that's my B. So my function is going to be f of x equals 20,000. Still with me? Times 0.99 to the x.
Oh, is that 1% or 11%? It's 1%.
My percent symbol. Now, I'm not sure why they want us to rewrite it as an exponential. It doesn't make sense to me, so we're not going to. We're going to use what we already know. This part right here, why rewrite it into this when I already have that? Does that make sense to you? It has e to the kx, so it wants you to figure out your e and do all your k and all of that. But I don't see the reason being when you have a fully working function. Does that make sense? So I'm not all about going around the mulberry bush. I'm saying use the skills you already have.
That's what number 10 on the other side was.
Yeah. Yes, I want you to process it, but don't
Wait, so do you
take it into
LN
full.
with that?
No. It tells us our x. What is our x? So we're looking for f of 48. And what do you do when you have your x value? You plug it in.
Okay, so we put 40 as the exponent.
So 48 is your exponent. Okay. For the sake of you seeing it, how College Board wants you, I'm going to write what they said for you to write in the calculator. Are you ready, guys?
Yeah.
This is fun. Here we go. It says 20,000, right? Then they want you to have it to the e to the x natural log of 0.99.
So what is the point when you could just plug it into the next exponential? That's weird.
And if you don't use ln, they want you to write log base e.
That is dumb.
But they shut up.
So see why I said we're not going to worry about writing it like this? You're going to get the same, you get the exact same answer, right? Exactly.
Simple.
And so I say stick to what we know. And what'd you get? 12,000. 0.0 what?
Wait, I got 1,002. Oh, that's 12,000.
12,200, 12,345? Yeah.
I got 745.
Is it around? I don't know.
So the F48 equals that.
what the undo button is for.
So is it F of 48 equals?
You should have.
I wouldn't. All right, so I am okay if you stick to doing what we already know how to do, and it's still gonna come out to be the same math. Does that make sense? Is this necessary to write in?
No.
No, it is not.
Why would you ever do that? Like,
I don't
why
know.
would you do that?
I don't know. I can't tell you, but I'm sure they have a great reason why they want you to do that.
I'm sure they don't.
I'm sure they do. Okay, all right. Number, I was gonna tell y'all, 13, don't worry about. It's using Desmos, and we're not gonna use.
So cross it off?
Yes.
What time is
It's
it?
using Desmos and calculating from there.
Dang, only 9:54?
Okay. So what did I say about 13?
Cross it off.
Cross it out. Got it? All right.